So again, good news is this is all review. This is stuff from Algebra 1, Algebra 2, okay, some stuff from this year, but this whole section is inequalities. So quick refresher on either the actual graphing of it or the notation of it. Okay, we solve these just like equations, except when you were dividing or multiplying both sides of the equation by a negative number. It will ask you to solve, it will ask you to graph, and sometimes it will ask you for the interval notation. So just as a reminder, if we're doing an inequality that's a less than or greater than, then we use a parentheses. So we used to use open dots, but when we get to interval notation, we use parentheses. Parentheses for the less than or the greater than without the or equal to. And then the brackets come into play with the or equal to. So if it's less than or equal to, you get a bracket. If it's greater than or equal to, you get a bracket. So the x is greater than -3. I want you to give me at least 3 numbers on your number line so I know the orientation. Like, so I would go 1 less than the number itself, 1 more than. So -4, -3, -2. And if it's greater than, it's going to be a parentheses, and it's going to be pointing towards the right. In interval notation, this answer would look like the number line, -3 to +infinity. So greater than means it points to the right, obviously would go on till +infinity. If x is less than 2, so now I get 1, 2, 3, less than is going to be a parentheses that points to the left. In interval notation, this would be -infinity up to 2 with a parentheses on the 2 because it doesn't include it. X is greater than or equal to 3. I now get 2, 3, 4. Bracket on the 3. Greater than would point to the right. Bracket on the 3 to +infinity. Correct. And then less than or equal to 4, 3, 4, 5. This one would get a bracket on the 4. And it would point to the left. So it would be -infinity to 4 with a bracket on the 4. Yep. So it's really just a different way of using notation. Usually when they switch from algebra to college algebra or algebra to pre-calc, that's when you start to see the switch from open dot to solid dot. Open dot to parentheses and then solid dot to bracket. So it means the exact same thing. It's just a different way. Most pre-calc books, and like this is obviously from the calc book, that's where the switch happens. So just pay attention if the instructions say to solve graph, then obviously you're doing that number line. And if it said solve graph, give interval notation, then you're putting it in interval notation at the end. All right, so example 1 says solve the inequality and then sketch the solution on the number line. Here you've got a fraction. You have 2 choices here. You could either distribute that in, or what I would recommend is get rid of that fraction by multiplying by the denominator. So I would multiply everything by 4. Now, when we multiply by 4, obviously it goes to the 9. This would be 36x. It goes to the -1, so -4, less than. It doesn't change that sign. This times 4 would actually cancel this denominator out before the 3 would get distributed in. So the 4 doesn't get distributed into that 16 because it would cancel. So this would be 3 times 16x minus 2. Then we would distribute. And then combine your like terms.
When you divide, it switches the...
By a negative. Divide or multiply by a negative, then it switches. Add the 6. Divide by 12.
So it doesn't change.
Nope, doesn't change this time. So this is actually read as x is greater than 1/6, and most of the time I would recommend the switch just because our brains read it that way. So put the variable on the left. Just make sure the large, like if the big opening is towards the variable, it stays that way. So this would be read as x is greater than 1/6. On a number line, you could do like 0, 1/6, and 1. And then greater than would be a parentheses pointed towards the right. Interval notation would be 1/6 with a parentheses to +infinity. Yeah, you're just establishing orientation. That's basically the idea behind it. 1 less than it, 1 more than it. So you know it's increasing. Questions on that one? All right, compound inequalities are inequalities that have two inequalities in them. If it is one statement and your variable is like in between it, this is read as an and statement. So if I read this one out loud, this would say -8 is less than or equal to -3x plus 5, which is less than 13. This is all built into one, and this is an and statement. When it's an and statement, okay, whatever you do to the middle, you have to do to both sides of your inequality. All right, so for this one, whatever I do to the middle, I have to do to both sides. You actually have two choices, I would say, for the middle. What would be one thing you could do? I could distribute the negative, right? I'll get a -3x and a -5. What else could you do? I could divide everything by that negative, okay? If you divide by the negative here, what happens to my signs? They both switch. So it's going to happen at some point. How many of you would have divided by the negative? How many of you would have distributed the negative? Okay, so let's do that. Either way, it would eventually cause the sign to change, so you're going to see it in a minute. But just remember that if you were to do it then, you have to flip the inequality sides. All right, so we're going to distribute. So -8 less than or equal to -3x minus 5, which is less than 13. Now I'm going to add the 5 in the middle, so I have to add it to the left and I have to add it to the right. -3 less than or equal to -3x, which is less than 18. And then I have to divide by -3, and here's where that flip is going to happen. So dividing by negative, this becomes 1. This sign changes direction. It still stays as an or equal to, but it does change direction. And this becomes x, and then this changes, and this becomes -6. So then again, to make sense in our brain, it should go from smallest to largest. So -6, the open part is pointing towards the variable, so it's going to stay that way, x, and then less than or equal to 1. So this is saying x is greater than -6, but less than or equal to 1 on a number line. If you just did -6 and 1, that's fine. Just make sure they're in order. Greater than, so if I just did this part, greater than 6 would be a parentheses, and it would point to the right. If I just did this part, it would be a bracket, and it would point to the left. But this is an and statement, so you're only taking the overlap, which is from -6 with a parentheses to +1 with a bracket. I don't know why that C is there, just ignore it. Yep.
When you add the 5, you do it to all the...
Whatever you do in the middle, you got to do to both sides.
Why don't you multiply by -1 to both sides?
Which
Or is it because you distribute?
we distributed. If you wanted to get rid of that negative, you would do it to both sides, and then it would flip your signs then.
Okay, but because it's distributed.
Right.
Okay.
Yep. Another thing you could see here is two separate inequalities. So you could see like 2x is less than 10, or x is, and let's say it's already solved, greater than or equal to 5, okay? That would be bad because that would be the same thing. So hang on. Greater than or equal to 6, okay? So when it's an or statement, usually they point out like the or's on a boat. So if I divided by 2, x would be less than 5, or x would be greater than or equal to 6. On a number line, this would be 5, 6, less than would point left, greater than or equal to would point right.
So there's no overlap.
So there is no overlap, but it's fine. If this was an and there was no overlap, then it's a problem, it's a no solution. But because it's or, it doesn't have to overlap. So this answer in interval notation would be -infinity to 5 with a parentheses, and then this little u means union, which is like an or, and it would go 6 to +infinity. So that's what your answer would look like if it was an or statement, okay? Again, they usually look like ors on the boat. Ors could also be all real numbers. Like if these overlapped and point in both directions, that would be an or statement. That would be an all real number solution. And then if it was an and, so like special cases on the and is if you point this way and you point this way, there's no overlap and it's an and, then that would be a no solution. So something like x has to be less than 1 and greater than 3. That number does not exist. That would be a no solution, right? There is no number that is less than 1 and also greater than 3. So those are special cases on your inequalities. All right. Then you get absolute value with your inequalities. All right, so absolute values with inequalities take on these characteristics. If it's an absolute, first of all, you got to isolate the absolute value. But once you isolate the absolute value, so isolate first. Once it is isolated, if it is less than, so if the absolute value is less than something, that's an and statement. So if you actually like listen to the word less than, it ends in the word and, okay? Less than is an and statement. Great or is an or statement. So if it's an and statement, we take the number that's on the side that's given, we change it to negative and put it on the other side, keeping it as an and statement. So if I had absolute value of x is less than 10, this turns into negative 10 is less than x, which is less than 10. So that's how we get rid of an absolute value. If it's less than, we put the negative on the other side. We keep the sign going in the same direction and keep it an and statement. If it's greater than, then the negative goes on the other side. Negative 10, sign in the same direction, is greater than x, or x, and finish it off, is greater than 10. To make sense in your brains, I would say rearrange this. This would be x is less than negative 10, or x is greater than 10.
You said don't change the sign, but now isn't the sign going?
You do, like this sign, you mean?
Yeah.
That sign? Right, when you write the initial one out, you keep this in the same direction as that. We just changed it so that the x would come first. So that would change this. It doesn't change the value, it just changes which order you're writing it in. Yeah, like if you get x, negative 10 is greater than x, that's the same thing as x is less than negative 10. All right, so look at B. No, look at A. Okay, the directions say solve the inequality, sketch it so the solution's on the number line. So the first thing you want to do is, like, again, read that out in your head. This is a what statement? This isn't an and, right? Because it's less than. So I go negative 5 is less than x minus 7, which is less than 5. And then I add 7 to both sides. 2 is less than x, which is less than 12. So this is a number line. 2, 12. Both would get the parentheses. Mm-hmm. So interval notation would be 212 with parentheses on them. This is a what statement?
Impossible.
Impossible. Why is it impossible?
An absolute value can't be smaller than a negative. It can't even be negative.
Good. So x cannot be less, absolute value cannot be less than a negative number. It can't be less than 0. If you catch it from the beginning, you save yourself a crap ton of work because there's no solution here. If you don't catch it from the beginning, this is a less than, so this is an and statement. If you go to put that number on the opposite sign, I could put 5 is less than x minus 7, which is less than negative 5. I could keep going. 12 less than x, which is less than 2. And this is saying x is greater than 12. And this is saying x is less than 2. And there is no overlap. With an and statement, you have to have overlap. So there's two ways to catch that. One, save yourself some time. In the beginning, absolute value cannot be less than 0. So if it's less than a negative, that would be less than 0. Or go through the steps of the work, look for your and overlap, and it doesn't happen. All right, C. This is what kind of statement? Good, it's an or statement. So negative 5 greater than or equal to 2x minus 7, which is greater than or equal to 5. Add the 7 to all three spots. 2 is greater than or equal to 2x, which is greater than or equal to 12. Divide by 2 in all three spots. But this is an or statement. So you could have split it here. There's two ways to do it. I could have split it here, and I would only recommend that if you know you're going to forget. Split it. So -5 is greater than or equal to 2x minus 7, or 2x minus 7 is greater than or equal to 5. Like, you could split it there, or wait till you get to the bottom. This is just, don't forget, this is actually an or statement. So 1 is greater than or equal to x, or x is greater than or equal to 6. And it can be done. So if it's an or statement, obviously it can point out. So this would be -infinity to 1, or, which is a u, 6 to positive infinity. The other, like, special case on something like this would be, well, hello. Did they catch you in student services?
Did they what?
Okay, so if you have something like this, let's say absolute value is greater than or equal to 0. What's true about every single absolute value? It's positive. What's true about every single number that is greater than or equal to 0? It would be positive. So this is a scenario in which you could actually answer this, so this would be all real numbers. This, without doing it, you would know that every single absolute value is going to be greater than or equal to 0. Or you could, it's a great or then, there's no opposite to 0. It would be 0 is greater than or equal to 2x minus 7, or 2x minus 7 is greater than or equal to 0. I would go through the motions of solving it. Add the 7. And this would be at 7/2. The one on the left is saying less than, right, if I switch this, less than or equal to 7/2, so bracket pointing that way. The one on the right is saying greater than or equal to 7/2. It would be a bracket on 7/2 pointing to the right. And this or is anywhere, and this whole number line is colored in. So this is why it would be all real numbers. So if there's an overlap going in opposite directions and it's an or statement, or it's like just like this where they literally, you just highlighted the whole thing, that would be an all real number scenario. So you could either catch it from the beginning and save yourself a little bit of time, or you could go all the way down and then save it and then solve it. Questions on that one? All right, last slide. And this is quadratic with inequalities. So when you have quadratic, meaning x squareds, okay, you're going to solve the quadratic like you would normally solve a quadratic. So x will equal usually 2 values. And then you're going to set up your number line, and you have to test points on this one. So this is where you're literally going to set it up. You're going to get a number here. You're going to get a number here. And then you plug in a point from here. You plug in a point from here. You plug in a point from here and see which ones work. Usually it's every other one works. There are exceptions, like if there's a repeated term, okay, a repeated answer, that messes up your pattern, but usually it's a repeated number. All right, so for A, yeah.
When you test points, like if it's an and statement, the one in the middle should work and the other two wouldn't.
Well, but it won't be, yes, and it depends on how you have your quadratic initially set up to identify the and the or. Yeah. So like if you look at A, there's two ways to solve this. One is I solve it. So I like pretend like it's x squared equals 16. And then I can either square root both sides, right? And then putting the plus and minus in the front. So that's my even root property. I would get x equals plus and minus square root 16. X equals plus and minus 4. That's one way to solve it if it was just quadratic, not inequality now. The other is to move the 16 to the other side and then factor. And then split and solve, and I get my -4 and +4. So either way you do that, you get your two zeros would be at -4 and +4. And then you're going to test points. So my advice is pick the easiest one, right? Like 0 is probably the easiest. Plug in 0 to here. So 0 squared minus or less than or equal to 16. 0 is less than or equal to 16, so it works there. Which means if I plug in -5, I'd get 25 is less than or equal to 16. That should not work. And if I plug in +5, 25 is less than or equal to 16. That does not work. So again, unless an answer is repeated, your pattern should be every other. This is an or equals, so it gets a bracket on those two zeros, and then I would shade in between. So -4 to 4 would all be solutions that would work in this inequality.
You don't have to bring it over, right? You can just like solve it like equal.
Correct.
Like when you change the sign or anything.
Nope. All right, look at B. So here's what people do on B. Square root both sides and put a plus and minus in front. Then what? Plus and minus 1, right? So there's two equations here.
Oh, can't you just add?
Yep. But you got to split it. And then positive. Then add the 3. X equals 2 and x equals 4. What you cannot do there, which is like what I've seen happen, is literally take the x minus 3 and like duplicate it and set them both equal to 1. That doesn't work. Like it only works like that if it's 0 on the other side. The other option is actually expand and FOIL that, move the 1 over, and then try to factor it again, which I wouldn't advise. I would just go with what we did. So now these are my two zeros. So on my number line, I'm going to do 2 and 4. Again, plot the easiest number, which is 0, which would be left of that 2. Plug it in here. So 0 minus 3 squared greater than or equal to 1. Negative 3 squared would be 9, which is greater than or equal to 1. Which means something like 5 should work. 5 minus 3 squared greater than or equal to 1. 2 squared is 4, and 4 is greater than or equal to 1. So consistent with every other. They get brackets, and they point out. If I plugged in 3, I would get 0. That is not greater than or equal to 1. So you do not need to plug in more than 1 point. I would say if this was a quiz or a test question, I would make sure by just plugging in. Next Wednesday.
And that one will be dropped.
Well, your lowest will get dropped. Hopefully that's not the lowest.
Okay.
Yeah.
Wait, say it again. The lowest will be dropped.
Hopefully a quiz on review sections is not my lowest grade. These should be easy. Should. Okay. All right. C. What do we do? Move the 16 over. X squared minus 6x minus 7 is less than 0. Then factor. Factors of negative 7 that sum to negative 6. Almost. Negative 7 and 1. And then split and solve. So those are the two zeros. Negative 1, positive 7. 0 would be in between them. You actually have two choices. You could plug the 0 in here, or you could plug the 0 in here. Actually, I have three choices. Or you can plug the 0 in here. It doesn't matter where you plug that in. If I do it in the top, I'd get 0 minus 6 times 0 plus 9, or 0 squared. 9 is less than 16, so the middle range works. It's a parentheses, and it's pointing in between. Again, if I wanted to be sure, I'd plug something less than negative 1, greater than 7, and see that it does not work. You actually get to work on it in class tomorrow if you're here, because there's another exam tomorrow. Questions on that? When I factor this, it's both 3s. So I only have one answer. So now I plug from the right or the left. It's going to go one way or the other. So if you plug in 0 from here, 0, 0, 9 is not less than, and I know to go that way. So those are really the only special cases. If you had 3, which we're not doing now because these are quadratic, but like let's say it was x to the 3rd and there were 3 terms, now it would be every other pattern like that. Unless 2 were repeated. So like if I had 3, 3, and 1, now my every other pattern's kind of messed up because my 3 is repeated. So the only time it really messes anything up is if you have a repeated answer.
Would we have one that's like 4 and 6 and equals to
it shouldn't happen. Yeah.